short में we write as POSET or partial order set? Partial order set. So said to be partial order set if satisfied the following properties. Under relation less than equal to. Here we symbolize as less than equal to be the relation. So first that means satisfy reflexivity. Reflexive. Second is antisymmetric. And third is transitive. So if satisfy these three properties, then any non-empty set is said to be a POSET. So we given one example. So we take the examples set of all the sets and relation is defined as is subset of. That means relation is defined as subset of. So is a example of POSET. Is an example of POSET. So that means subset of. So first the reflexive property. Every set is subset of itself. Satisfy the reflexive. So we can write as for first that means reflexive. Every set we can take a set A. A is subset of A. So every set is subset of itself. So this is a reflexive. And second is antisymmetric. For antisymmetric relation, we write as A is subset of B, A subset of B, and B subset of A. B subset of A, which implies that A equal to B. So this type of set, that means we satisfy this property called antisymmetric relation, antisymmetric, and the third transitive. So for transitive, that means A is subset of B and B is subset of C, which implies that A is subset of C. Obviously, A subset B है, B subset C है, so then A is subset of C. So that means the relation is subset of is a POSET. So the relation subset is a POSET. Short में जब हम इसे symbolize करेंगे, so we can write in this form. That means POSET we can take as P, and under the relation we take as less than equal to. This is the relation which symbolizes as less than equal to. So generally authors write in this form less than equal to. इस less than equal to के place पे हमें इस previous question के लिए क्या लेना है? Subset. So that means previous question को अगर हमें mention करना होगा, तो we mention in this form. So we can write the is a POSET. So we write this form is a POSET. But generally we use this less than equal to sign for defining a relation. For defining a relation. So we take other examples which satisfy all these three properties, such as reflexive, antisymmetric, and transitive, is called the POSET under the relation, which relation may be divides of, subset of, okay, multiplication, or any other particular defined relation. Okay. So now we move to the next definition, which is Hess diagram. So this is the important part after defining the POSET. So Hess diagram. So we can define Hess diagram as this is a graphical representation. Okay, Hess diagram, or you can write as representation of POSET. Simply you can write as representation of POSETs. Hess diagram or representation of POSET. So that means we define as the Hess diagram is a graphical representation. Graphical representation of POSET under the defined relation. Under the defined relation. So any relation is given, under the defined relation, we draw the Hess diagram. That means any POSET is given, we just draw the Hess diagram of the POSET. For example, if we have set A is equal to 1, 2, 3, 4, 6, 12, 24 and 48, and the relation is defined as is divides. Relation is defined as is divides. So draw the Hess diagram. Draw the Hess diagram. Set A is given in this form and relation is defined as it divides. That means 1 divides 2, 1 divides 3. So in this form we make a Hess diagram. So how to make Hess diagram for using these elements? So initially we start with the element 1. Okay, so now we start from lower side. So we take the element 1. The element 1 which divides 2 and 3 both. That means 1 is divided to all elements, but initially we take as 1 divides 2 and 1 divides 3. So we draw as 2 and 3. 1 divides 2 and 3. Now next element are 4 and 6. So where we take 4, that means only 2 divides 4, but 3 cannot divide 4. So we take as 4 here. So 2 divides 4 and 6. So we take 6 here, that means 3 divides 6, but 2 also divides 6. 3 divides 6, but 2 also divides 6. So we join 2 to 6 directly and 3 to 6. So we are here, that means cover 1, 2, 3, 4 and 6. 5 elements we have covered. Now we move to the next element, which is 12. 12, so we see that 4 divides 12 and 6 also divide 12. Okay, so we can take 12 as here. So 4 divide 12 and 6 also divide 12. So we write as 12 here. Now we see that the next element is 24. So 12 divide 24. So we write directly above. That means this is 24. So 12 divide 24 and 24 divides 48. So 24 divides 48. So this is the Hess diagram for particular given set. is divides. So how to draw this Hasse diagram? Relation is divides. So in previous example, we take 1 as the initial element, that will that divides 2 and 3. But in this case, we take two initial elements, which are 2 and 3, which are 2 and 3, because 2 and 3 both divide 6. 2 and 3 both divide 6. And 6 divide 12. 12 divide 48, or 48 divide 96. So this is the Hasse diagram for this. So that means there is no boundation for maximal or minimal element. That means next definition we defined for calculating or determining the maximal element or minimal element of any Hasse diagram. So पहले तो अभी हमने this question we understand or we learn how to draw the diagram, and after drawing the diagram we identify maximal element and minimal element of the Hasse diagram. Okay, so now next definition we write as a maximal element or minimal element. Maximal element and minimal element of Hasse diagram. So let A be the set and small a be the element of A. So then set to be the maximal element if all the element, that means all the element of Hasse diagram which is less than equal to A. That means for every x is also belongs to A. Maximal element, that means जो A element हमने लिया है वो सबसे टॉप एलिमेंट हाईएस्ट एलिमेंट होगा, उससे ऊपर कोई एलिमेंट ही नहीं होगा, तो दैट इज द मैक्सिमल एलिमेंट. x भी x क्या हो गया, वो अदर एलिमेंट्स हो गए which also belongs to the Hasse diagram, but for maximal element that means x is less than equal to A. So A is the highest element. Or similarly case of minimal element, so for minimal element that means we write directly for minimal element यहाँ पे क्या होगा, a जो होगा वो क्या होगा, लेस देन टू द x. सो दैट मींस a स्मॉलेस्ट एलिमेंट होगा, x क्या होंगे, अदर एलिमेंट्स होंगे, उनसे सबसे छोटा एलिमेंट दैट इज कॉल्ड a. So that is the minimal element. So a less than equal to x, for every we write as x belongs to a, or this a also belongs to a. This a also belongs to a. So a is said to be the minimal element. So a is minimal element. A is minimal element. Now we return back to the above example. We understand the definition. When we write the definition as maximal or minimal element, so how to calculate or obtain the minimal and maximal element of above example. So when you understand the definition, so tell me about the minimal elements of this set diagram. 2 and 3. So the minimal means lowest element. तो उनके दोनों एलिमेंट्स के अलावा और कोई भी लोएस्ट एलिमेंट नहीं है उस सेट में, बाकी और एलिमेंट क्या है उससे हायर हैं, बड़े एलिमेंट्स हैं. तो हमने यही लिखा है कि a लेस देन इक्वल टू x. जो a है वो सबसे छोटा एलिमेंट है, लीस्ट मतलब मिनिमल एलिमेंट. सो जो दिस इज 2 and 3, so these are called the minimal element. these are called minimal element. So 2 and 3 are the minimal element, and 96 that is the maximal element. मतलब उससे ऊपर कोई element ही नहीं है. So that is the maximal element. 96 is the maximal element. So we identify. अब यहाँ पे हमने देखा that means the minimal and maximal element cannot be unique. Both the element cannot be unique. More than one हो सकते हैं आपके. According to the Hess diagram, here we see that there are two minimal elements, and similarly when we have other elements, that is suppose 96 and other element also, so maybe more than one maximal element. Okay, so the minimal and maximal elements are not unique in a Hess diagram. So remember in the note, so we write here also, the minimal and maximal element are not unique. The minimal and maximal element are not unique. Minimal and maximal elements are not unique, which may be more than one. But we talk about lower bound and upper bound. We talk about the lower bound and upper bound. So when we calculate lower bound and upper bound of any Hess diagram, they are unique. Lower bound and upper bound, they are unique. They are unique. So how to write the lower bound and upper bound as previous example? So the lower bound means minimal element. So minimal element, we see that there are 2 and 3 are minimal elements. So we can write that there is no lower bound. There is no lower bound. If we got only unique lower bound, then we write, otherwise we do not write. And upper bound means maximum value. So which is a maximum element, that means that is a unique, which is 96. So for previous example, we do not write again and again examples. So for that means we write as upper bound. So upper bound of this is 96, and we talk about the lower bound. Lower bound is none. So that means there is no unique element in the lower bound. So lower bound is none and upper bound is 96. Clear? Both the definition, maximal element, minimal element क्या होंगे, lower bound उसका और upper bound क्या होगा, ठीक है? Now we take an example. We have a set D8 and the relation is defined as it divides. This symbol shows the divides. You remember, this symbol shows the divides. So D8. So draw the Hess diagram. Draw the Hess diagram. So D8 means we factorize 8. So how many factors 8 have? So we write set A, or we can write the, how to write factors? 1, 2, 4, 8. 1, 2, 4, 8. So 1, 2 and 4, 8, and relation is defined as it divides. So how to draw the Hess diagram? So we take 1, then 1 divides 2, then 2 divides 4, and 4 divides 8. So this is the Hess diagram. This type of Hess diagram is called chain. अगर कोई ऐसा straight line बना रहा है Hess diagram, तो that is called chain. So any Hess diagram, you remember, any Hess diagram which makes a chain, that means which make a straight line, is called a chain. straight line is called a chain. So remember, we have required this word chain in lattice. Now, in this example, when we obtain lower bound, upper bound, maximal, minimal elements, so all are exist. All are exist. So minimal element 1, minimal element 1, maximal 8, lower bound 1, and upper bound 8. So lower bound 1 and upper bound 8. Upper bound 8. अब आपको इसी में क्वेश्चन को मॉडिफाई किया जाए. दैट मीन्स व्हाट इज द अपर बाउंड ऑफ 2. दैट इज स्पेसिफाई कर दिया क्वेश्चन को. तो व्हाट इज द अपर बाउंड ऑफ 2? 4. So particularly for this set, that means we talk about the upper bound of this 2, element 2. So upper bound of 2 is 4. Okay, so try to one question, draw the Hasse diagram for this. Try to do. A is equal to ABC. A equal to ABC. We have 3 elements in set A. And draw the Hasse diagram for power set of A. Draw the Hasse diagram for power set of A under the relation is defined as the subset of. Draw the Hasse diagram for this. Question समझ गए आप? Set A having 3 elements A, B, C. First we make the power set of this set, and after making the power set, we draw the Hasse diagram. Relation is defined as a subset of. So try to draw this. Ashish. So first you write the power set elements, which are 5, A, B, C, AB, BC, AC itself. ABC 1, 2, 3, 4, 5, 6, 7, 8. Having 8 elements. Now we draw the Hasse diagram for this. So when you want to draw the Hasse diagram for this, that means what are the initial element? 5, because 5 is subset of every set. Empty set is subset of every set. So we take the element 5 here. So this is 5. 5 is subset of A, 5 is subset of B, 5 is subset of C. Okay. Now the above elements are, first we take as AB. We take as AB. So this set A is subset of AB, we join. B is subset of AB, we join. Now we take as second element as BC. For BC, B is subset of BC, C is subset of BC. Now third we take as AC. So we take AC. So for AC, that means C is subset of AC and A. A is subset of AC. And last we take as ABC. So here we take as ABC. So that means AB is subset of ABC. This is subset of ABC, and this is subset of ABC. So this is the Hasse diagram for the given power set of A. Okay. This also have unique lower bound and upper bound, and minimal element and maximal element also. Lower bound is 5, upper bound is ABC. And same for we write minimal and maximal. Greatest lower bound and least upper bound, GLB and LUB. You write the definitions only. Okay, so note down the definition. That means the least upper bound is also called the supremum, and the greatest lower bound is also called the infimum value. So for calculating the least upper bound, we write as P be any POSET or A be any subset of P, then element X belongs to P is said to be the least upper bound if X is an upper bound of A. X is an upper bound. So that means we already defined upper bound and lower bound. तो वही जो upper bound होगा, that is called least upper bound if all the element, that means of the given set is less than equal to the that set. That means having least upper bound and greatest lower bound is also unique. आप उसी अपर बाउंड को ही लीस्ट अपर बाउंड बोल देंगे, ठीक है. देयर इज नो अदर एलिमेंट अबव दैट एलिमेंट. एंड ग्रेटेस्ट लोअर बाउंड मींस इनफिमम वैल्यू. इनफिमम वैल्यू वो भी जो आपकी लोअर बाउंड होगी, विच इज आल्सो यूनिक. सो दैट इज कॉल्ड आल्सो द ग्रेटेस्ट लोअर बाउंड और इनफिमम वैल्यू, which is also in the form of the uniqueness. So that means this is also unique, and greatest lower bound is also unique. अब ये infimum और supremum, that means we can calculate in between elements also. So we take an example. So you understand this example? नोट कोई बात नहीं, नोट मत करो, लेक्चर ओपन कर दूंगा, उस पर डाल दिए मैंने, करना है कर लो, कोई दिक्कत नहीं, नोट करना है कर लीजिए। नहीं कराना है। Okay, so we can take this example. So that means we have 6 vertices, that A, F, B, C, E, and G. So now we calculate upper bounds, lower bounds. So specify when we want to calculate the upper bound of C and E. So what is the upper bound of C and E? We can say that directly D. D is the upper bound of C and E. We write the upper bound of C and E is D. What is the least upper bound? Least upper bound means supremum value of C and E. So that means supremum value is also D, because there is no other value of above the D. So D is the highest value, which is the upper bound, और उससे above भी कोई value नहीं है for particular this one. So that means D is also the supremum value of C and E. And now we talk about the lower bound of CE. So what is the lower bound of the CE? So that means this is the least value. So this is the lower bound of CE, and same as for greatest lower bound, the infimum value for this set, that means C and E, is also B. Because the lowest upper bound and greatest lower bound is also in the form of the uniqueness. That means unique, not taken 2 or 3. So we write as the infimum value, that means greatest lower bound is of C and E is also B. Same we modify this question, that means when we talk about what is the least upper bound of B. So how to write least upper bound of B? There is no least upper bound, because we have 2 upper bounds C and E, so which are not in a unique form, which are not unique. So there is no least upper bound of B. Same case of greatest lower bound or infimum. So there are 2 infimum value of B, which are A and F. So which is also not in unique form. So there is no least upper bound or greatest lower bound of this case. Okay. So for particularly, you can check, that will be fixed for this one, be fixed for this one, and above. So on the basis of these 2 definitions, least upper bound and greatest lower bound, we define lattice. Lattice, so that means every non-empty set under some definition, that means taking relation less than equal to L be any non-empty set, less than equal to be any relation, be a POSET. POSET means satisfy, reflexive, antisymmetric, and transitive. Then L is said to be a lattice if it has a least upper bound and greatest lower bound. कोई भी ऐसा एग्जांपल जिसमें हमें लीस्ट अपर बाउंड भी मिल रहा है और ग्रेटेस्ट लोअर बाउंड भी मिल रहा है इस एलिमेंट का, वो सेट आपने हेल्थ डायग्राम ड्रॉ करे, ठीक है। हेल्थ डायग्राम ड्रॉ करने के बाद उस हेल्थ डायग्राम पे दैट मींस वी कैन ऑब्टेन लीस्ट अपर बाउंड एंड ग्रेटेस्ट लोअर बाउंड, देन दैट हेल्थ डायग्राम इज सेड टू बी अ लैटिस. ऐसा किन केसेस में पॉसिबल है? सिंपलेस्ट एग्जांपल वी वांट टू गिव इट, दैट मींस एवरी चेन इज द एग्जांपल ऑफ लैटिस, because every chain having minimal element, maximal element, upper bound, lower bound, least upper bound, and greatest lower bound, all are exist in a chain. Okay, so when we talk about the 1 and 8, this is a D8 and the relation is divides of, so having minimal element 1, lower bound 1, and the greatest lower bound infimum value also 1, and the supremum value having 8. So that means this exists both least upper bound and greatest lower bound. So this is the example of chain. कोई भी ऐसा एग्जांपल जिसमें हमें लीस्ट अपर बाउंड और ग्रेटेस्ट लोअर बाउंड नहीं मिल रहा है, दैट इज नॉट द एग्जांपल ऑफ चेन. दैट मींस फॉर एग्जांपल हमने कोई दो एलिमेंट्स लिए, जैसे फॉर एग्जांपल 2 and 3, and here we write as 6 and we write as 12. Is this example of lattice or not? Not example of lattice, because we have two